Welcome back. Now we know how to create an instant gameplay effect, and applying that gameplay effect is relatively simple. And we applied it using a blueprint callable function, which we're calling here in response to an overlap. Now, before we move on to different duration types for gameplay effects, we should visit how to apply these gameplay effects directly here in Blueprint without having to call a blueprint callable C++ function. And our C++ function here in Aura Actor involves getting the ability system component for the target simply so we can use it to make an effect context and apply a gameplay effect after making an effect spec. This is actually quite simple to do here in Blueprint as well. We can take our other actor and we can call get ability system component. And if we hover over this, we see target is ability system blueprint library. And that's the function we ended up calling here, ability system blueprint library get ability system component, which takes a target actor. Here we have the input actor, and the return value is the ability system component. Now, once we've gotten that ability system component, we take it and make an effect context with make effect context. We can do that here in Blueprint. We can drag off of the return value and type make effect context. And this function returns a gameplay effect context handle structure. Just like make effect context here in C++ returns a gameplay effect context handle struct. Same thing. Now here in C++, we're calling this add source object function. Now if we go to the definition of this, we'll see here that it exists in gameplay effect types, and it's right here inside of, scrolling up, our fGameplay effect context handle. But we see that this function is not blueprint callable. So we can't call this from Blueprint. We also have get source object, which is also not blueprint callable. But here in Blueprint, if we type in source object, we see that we have a get source object. So how can we call this in Blueprint if it's not blueprint callable? Well, this is not a function on this struct. It's a function on ability system blueprint library. So these static libraries are a great way to expose to Blueprint certain things that you can only do in C++. And later on in the course, we'll be making our own Blueprint library that we can use to expose certain utilities to the Blueprint side like this. So while we can't call add source object, we could make a static function library, a Blueprint library of our own, and create a static function that could take in an effect context and call a function such as add source object, for example. So that's one of the limitations of doing this from Blueprint. But closing gameplay effect types and going back into Aura effect actor, the next thing we did was we made an outgoing spec, this gameplay effect spec handle. This is a function on the ability system component. So from here in Blueprint, we could drag off and type make outgoing spec. And notice that make outgoing spec requires a gameplay effect class, which we have one here. We have instant gameplay effect class. If I duplicate that node and plug it in, that will satisfy it. We can also set the level. In C++, we set it to 1, and it takes a gameplay effect context handle structure. That's what make effect context returns. So we could simply plug that straight in there, and we now have an outgoing spec. Now the last thing we did here in C++ was call apply gameplay effect spec to self on the ability system component. Here in Blueprint, we can take our ability system component and call apply gameplay effect spec to self. We see that there are other options here as well. But if we choose apply gameplay effect spec, not effect, but effect spec to self, then we see that we can plug in a spec handle. That's the return value from make outgoing spec. So as you can see, this looks a little bit cleaner in Blueprint. As here in C++, we had to get the effect spec handle and get the data, which is a pointer wrapper. We had to get the raw pointer and dereference it in order to pass in that object. Here in Blueprint, we don't have to do any of that. We just call a handful of functions that are exposed to Blueprint, and it's a little bit easier, a little quicker to do, but you can do it either way. And we've seen that on the C++ side, we do have more options, as not everything in C++ is exposed to Blueprint. And another benefit is we did all this work in C++ right here in our Blueprint callable function. So the end result is that our Blueprint is cleaner, as we only have a single node. And as things get more complex, we'll be able to implement those in C++. But really, using one versus the other is really not going to result in, say, a significant performance difference, at least in this case, as we're doing simple things here. But to make sure that this works, we could bypass our Blueprint callable node, and we can simply call apply gameplay effect spec to self and simply destroy the actor after that, like so. And if we wanted to make sure that this only works for an actor that has an ability system component here, we can add an isValid to the ability system component. We can say isValid here, use the one with the question mark, and run it through the isValid node first, like so. And we can tidy this up just a little bit. This does get a little bit messy in Blueprint. Another reason to opt for the C++ option, as blueprints can get a bit out of hand. And ideally, this could be collapsed into a function of its own and cleaned up even further. But let's just make sure that we can prove to ourselves that the Blueprint option works. Let's go and pick up the health potion. That's the one that we changed. And we see that it works. And we're not using the C++ function anymore. Now we're using the Blueprint option. So 2 options for you. And I'll just leave those nodes there for now. But we're using our C++ function. Okay, great. Just moving that out of the way. Now for the topic of this lecture. And I'll just vocalize it. I hooked up destroy actor and everything's back to how it was there. Now the topic for this lecture is the different types of duration policies for our gameplay effects. We have a GE Potion Heal, which is an instant gameplay effect. Our Potion Mana is also an instant gameplay effect. But instant is just one of 3 choices. We also have infinite and has duration. In this video, I'd like to discuss has duration and see how the has duration type works. So to showcase the has duration gameplay effect, I'd like to make a new one. I'm going to right click here and create a new Blueprint class. I'm going to search for gameplay effect, choose that class, and call this one GE underscore. And this will be the duration based heal. So I think I'd like to use something other than a health potion. The assets folder in this startup project has a crystal. So I'm going to say crystal heal, and we can make maybe a healing crystal, for example. So I'm going to open up crystal heal, and here in the details panel, I'm going to scroll down to the duration policy and change it to has duration. Now that it's has duration, we need to specify the duration magnitude. Essentially, how many seconds is this effect going to be applied before it removes itself? So for the duration magnitude, we have scalable float, attribute based, custom calculation class, and set by caller. So far, we only have experience with scalable float, which, as we know, we can hard code a value in, and we can also scale it by a table. Now, we haven't created a table yet. Don't worry, we'll get to all these features. We're going to cover them all. But I'm going to set a scalable float magnitude of 2. And this is in seconds. So this effect will be applied for 2 seconds, after which it will remove itself. And if we have any modifiers here, those modifiers will be undone. So for example, if I want to modify one of my attributes, I can add a modifier with the plus icon, and I can select the attribute. Let's say I want to select max health. And for max health, I'd like to add to it. And for the modifier magnitude, expanding that, I'm going to set the scalable float magnitude to 100. So in other words, the max health will be added to by 100. Now, the max health is already starting at 100, which means it will be now 200 for 2 seconds. And the result of that is we should see the health globe actually appear to go down because the amount of health, the current health value health, is going to be the same, but max health will be larger, which means the percentage of health will be the same value divided by an even larger value for max health. So we should actually see that health globe go down. It'll look like you have less health. You really have the same amount of health, but the max health has changed. So we have this crystal heal, right? And we want to apply this duration-based effect. And we can easily do that by creating a new blueprint based on our Aura effect actor and setting its effect, but we called our effect instant gameplay effect class. We should add a new variable for a gameplay effect that has a duration. So what I'm going to do is I'm going to save all, I'm going to close the editor, and we're going to add one more variable to Aura effect actor. We'll go ahead and rearrange these here. I'm going to close out of the files I'm not using. And just under instant gameplay effect class, I'm going to add another T subclass of holding a gameplay effect. And this one will be called duration gameplay effect class. So we'll have a different variable here. So what we can do is now we can make a blueprint for the health crystal that actually applies the duration gameplay effect and not the instant gameplay effect. So that's what we'd like to do. And that's going to be your quest. I'd like you to create the health crystal blueprint. You can call it BP health crystal if you like. And you're going to set that duration-based gameplay effect on this blueprint, and then go ahead and apply the effect. You can use our blueprint callable function we created, or you can get some practice doing it all in Blueprint. Go ahead and make that choice. So pause the video and conquer this quest now. Okay, so now that I have my duration gameplay effect class, I'm going to go ahead and run this in debug mode so I can make the blueprint and test it out. All right, so back here in the editor, I'm going to make a new blueprint, right-click, blueprint class, and I'm going to base it on Aura effect actor. Choose that. And I'm here in the potion folder, and this is a crystal technically, but that's okay. I'm just going to keep it here in the potion folder. It's basically another type of potion. And I'm going to call this health crystal. I'm going to open health crystal. And I'm going to need a mesh and some kind of overlap volume. So I'll do that first. I'll select the root component, create the static mesh, simply call this mesh. Actually, I'll call this crystal mesh. And I'll search for crystal. And it looks like we have a static mesh called health crystal, and it's quite large. So I'm going to scale it on down by about 0.2. in each dimension, and I'll add a collision volume. And for this one, since I can, why not, I'll go ahead and add a capsule. So I'm going to get that capsule in here. I'll just leave it named capsule, and I can adjust its size a little bit, like so. And the center of my crystal isn't perfect, so I'm going to take that crystal mesh and just move it a bit so it's centered without snapping on, like so. If I wanted to be precise, I could go from perspective to left and move it more precisely, and go to right and move it more precisely. All right, looking good. I'm going to make sure my crystal mesh has no collision. Some of those things you typically do for things like these pickups. I'm going to go to my capsule collision settings here, And it's set to overlap all dynamic. I'll just leave it at that. That's fine. Set to generate overlap events. Perfect. And I'll go to Health Crystal Self and search for Duration. And here's Duration Gameplay Effect class. I'm going to choose my GE Crystal Heal. And now we have that set. And Instant Gameplay Effect class, I'm going to leave unset. And in the event graph, I'm going to take my capsule and use onComponent begin overlap. And I can either use my blueprint callable function to apply the effect, or I can do everything in blueprint. I'm going to use my apply effect to target a blueprint callable function. And I will plug in other actor as the target actor and use my duration gameplay effect class as the gameplay effect. And I'll go ahead and destroy. So destroy actor after this. All right, now all that's left is to test it out. I'm going to compile and save and drag out a BP Health Crystal blueprint. I'll bring it out here. I'm going to save all and playtest. Now we should see, because our health will be the same value, but our max health will be twice as large, this should go down. And I can even show debug. Remember to click in the viewport before hitting tilde key. Show debug, ability system. And I see health is 50, max health is 100. Let's pick up that healing crystal. And now we see max health is 200. Oh, but now it's back to 100. Why? Because this is a duration-based gameplay effect, and we set the duration to 2 seconds. Let's see that again, because 2 seconds isn't a long time. Here's the health. Goes down, but 2 seconds later, it comes back up. Now, this is extremely useful because without that built-in capability of gameplay effects, we'd have to create our own timers and create callbacks for when the timers finish, and it's all a lot more work, whereas all we needed to do was make a gameplay effect and just set its duration and the duration magnitude, and it was quite easy. Now, setting our max health to what it was plus 100 for 2 seconds and then setting it back to what it was before, that's kind of silly. It's not really a gameplay mechanic that you would think up and decide to implement in a game. This was just for demonstrating how a duration-based gameplay effect works. But in the videos to come, we're going to see how we can have a gameplay effect apply changes periodically. In other words, every so often, apply some kind of change, such as healing over time and things like that. And those are the type of things that you would see in a game. So great job this video. We learned about duration-based gameplay effects. We're still going to make this aura effect actor a little more flexible. So we'll do that in the videos to come. Great job. I'll see you soon.